So let's get started. Today I'm going to give a brief review of the chapter about the probability distribution. So it will be a short video, it's not going to be too long. And let's jump right in. So when you look at the big picture of statistics, we have three main branches: descriptive, probability, and inference. Before the midterm, we have finished the descriptive statistics, which is basically some basic parameter like mean, mode, median, standard deviation, and also some graphic stuff like the stem and leaf graph, the bar graph, the time series, that kind of stuff. And then we come to the probability, and then come to the inference. So we are now at this point. So probability, when you talk about this, talk about probability distribution, there are two key concepts you need to keep in mind. One is the one value probability, and the other is cumulative probability. So let's look at these two examples. So when you are looking at the example of tossing a dice, so every phase will have the same probability to get. So you can see P of X is the same of all this value, 1/6 is the probability. So basically, the one value probability is talking about P of X at xi point. However, when you look at the cumulative probability, it's different. Cumulative probability is saying that I want to know the probability x less than or equals than xi, which means it is cumulative. Just look at this as an example. So P of x which less than x less than 2, which means you need to add up the probability of px equals to 1 plus px equal to 2. So you will end up getting 2/6 because this is 1/6 plus 1/6. So this example is a discrete example. When you look at the normal distribution, you will see normal distribution like this. And then, for example, x is here is 100. And the point you get, the value px equal to 100, maybe it's 0.1. So that is one value probability, the probability at a particular point. So when you look at the cumulative probability, px less than or equal than 100, which means you are looking at the probability that adds up to 100. So there's a totally different value, totally different concept. So keep that in mind and look at the most important things in this chapter is the normal distribution. So when you talk about normal distribution, one of the first things that come to mind is it is symmetric. The other thing is the empirical rule, which says 68.27% of the value, or you get a probability of 68% that your value will fall within the range from mu minus sigma to mu plus sigma. Mu is the mean, as we learned. And if you go to 2 sigma, which is mu minus 2 sigma to mu plus 2 sigma, you will got a probability of around 95%. This is important because we are going to use this later. And the other thing is that if you go outside 3 sigma, or in some case, you say you go outside 2 sigma, it's kind of an outlier. It's of very low probability. So the other thing is that we need to do a transformation to the standard normal distribution, and you need to calculate the z-score. So on the left-hand side, this is a normal distribution, which, as you can see, it has a mean, which is mu equals to 1010, and it has a standard deviation sigma of 20, because you can see this is 20. If you do the standardization, you will get to a standard normal distribution, which has a mu of 0 and sigma of 1. And the way you can do this transformation is using the formula right here. So for example, I want to do the transformation at point x equal to 150. So the z-score at this point would be 1050 minus mu, which is 1010, minus sigma, which is 20, which you get 2, which is absolutely what you can see here. Positive 2. So this equation is super important because you will use it very often. Just keep that in mind. And about the z-score, you will need to get to deal with the z-score table. Actually, there are different kinds of z-score table. So the first thing you need to check is the instruction, which is typically above the table, which is something like this. If you tell you that what is it calculating, what is it showing on the table? So z-score, typically the definition would be like this, which is a cumulative probability, which I've just mentioned. So it's a cumulative probability from the negative n to z. And since the normal distribution is symmetric, basically you just need, for example, this is the mu. You just need one end of the data, one end of the table, and you can get the other end by symmetric. So you will see on the table below the left table, you got all the z-score is positive. On the right hand side is negative. Just be careful about how you use it. So let's go through some examples. So here are two examples. You should pause the video and try to do it by yourself. It's quite straightforward. So I will go through it now. So the first one, it says the mean is 36 and the standard deviation is 10, which it says mu is 36, sigma is 10. Find a z-score of 33. So when you plug in the equation, plug in the values, 33 minus 36 over 10, which is negative 0.3. For z-score of 72, you got the same thing, 72 minus 36 over 10, which is 3.6. So the other thing is find the p-value, find the probability, so actually find the area. So it's always a good idea to draw this picture out in your draft paper. So when you talk about z-score, it's always on the standard normal distribution, and that's the reason why we need to transform them to standard form. So for the standard normal distribution, the mu is 0, sigma is 1. So when you try to find the z greater than 2.1, so 2.1 would be here. So which means you want to find the value on the right hand side. So it is actually equals to finding the value on the left hand side of the point negative 2.1, because you've got a table which has the value, all the values are negative value. So you go to find a 2.1 and find this value, and this is what you should get. The same deal is when z-score is less than 1.6, this is a little bit different. So let's draw the picture out. Let's draw it out here. So this is 1.6. It is asking for the probability on the left-hand side. So according to the symmetric, you can always get this, the value on this tail, by negative 1.6. And the remaining value, which is the left-hand side, is just 1 minus that value. So which means p z less than 1.6 equals to 1 minus p z less than negative 1.6. The last one, so p 0.4 z and 1.5, the value between 0.4 and 1.5. So when you go to the symmetry, you will find that the answer is Pz less than negative 0.4 minus Pz less than negative 1.5. So next question. So these questions, so the mean is 200. The sigma is 20. It's saying find the number of days which is within the lowest 10%. So what that means, the 10% here is area. If you got the area which is 0.1, 10%, you will be able to find the z-score according to 0.1. And you got the z-score. If you remember this equation, you will find that, oh, you got the z-score already. You know the mu, you know sigma, and you can always solve for x. And that's it for today's review. Thank you.